Hello everyone. In this video we will talk about discrete random variables. By the end of this video you will be able to distinguish between discrete and continuous random variable. You will be able to identify discrete probability distribution. You will graph discrete probability distribution. You will compute and interpret the mean of a discrete random variable. You will interpret the mean of a discrete random variable as an expected value. We will learn how to compute the standard deviation of a discrete random variable. A random variable is a numerical measure of the outcome from a probability experiment, so its value is determined by chance. Random variables are denoted using letters such as uppercase X. A discrete random variable has either a finite or countable number of values. The values of a discrete random variable can be plotted on the number line with spaces between each point. We learned previously about discrete variables, so a discrete random variable is similar in that manner. A continuous random variable has infinitely many values. The values of a continuous random variable can be plotted on a number line in an interrupted fashion. Here is an example. If we look at the number of light bulbs that burn out in a room of 10 light bulbs in the next year, then we're talking about a discrete random variable because that number of light bulbs could be 0, could be 1, 2, 3, 4, or could be 10. If we look at the number of leaves on a randomly selected oak tree, then we can have a discrete variable also. We can have the value of 0, 2, 3, 4, 5, 6, and etc. If we look at the length of time between calls to 911, then we will talk about continuous variable because the time varies. We could have a minute and a half, we could have 2 minutes, we can have 33 seconds, and etc. So since the time has fractions in this case, we're going to say the random variable is a continuous random variable. The probability distribution of a discrete random variable X provides the possible values of the random variable and their corresponding probabilities. A probability distribution can be in the form of a table, graph, or mathematical formula. One form that we saw before is the relative frequency tables. Relative frequency tables are usually probability distribution. Let's look at this table. This table shows the probability distribution for a random variable X, where X represents the number of movies streamed on Netflix each month. Notice how we have the possibility of streaming 0 movies, and the probability here for that to happen is 6%. 1 movie, 58%. 2 movies, 22%, and etc. If you think about it, the discrete probability distribution table is basically the relative frequency distribution table. The rules for a discrete probability distribution: let P of X denote the probability that the random variable X equals X. Then the sum of all probabilities should be equal to 1, and each of these probabilities should be between 0 and 1. In other words, if you add up all of the probabilities in a discrete probability distribution, you should get 1, and each of these probabilities should be less than 1 and greater than 0. In this example, if we look at this table to see whether it fulfills the probability distribution table conditions, we will notice that, first of all, each of these probabilities is actually less than 1 and greater than 0, so none of them is negative, and none of them is exceeding 1. So the second condition is met. But if you come to the first condition and add all of these probabilities, you will notice that the addition is those probabilities add up to 0.97, so that is not 1. And because of that, this table does not represent a probability distribution. If you look at this table, you will notice that the first thing that you can see here is the last probability is not positive, and it's less than 0, so it doesn't satisfy the second condition of the probability distribution or discrete probability distribution, and this makes it not a probability distribution. If you look at this table, let's examine. First, each of these probabilities is less than 1 and it is positive, so the second condition is met. And if we add all of these probabilities up, then we will end up with 1. So yes, this is actually a probability distribution table. To graph a probability distribution table, we learned in the past how to create a relative frequency histogram. So that's how we're going to graph any probability distribution table. From the previous example, we know this table represents the number of movies streamed on Netflix each month. And if we want to graph it, we're going to create a relative frequency histogram here using the data analysis tool, just like what we learned in the past few weeks. If we want to compute the mean of a discrete random variable, then we're going to use this formula. The formula says the mean for a discrete random variable is the sum of the multiplication of x and the probability. So basically, from the table, we multiply each value with the probability of the value and then add everything up, and that will represent the mean of that discrete random variable. Here is an example. If we want to compute the mean of the probability distribution, which represents in this case the number of DVDs a person rents from a video store during a single visit, we have this table. To compute the mean, first you need to multiply the values by the probability. So 0 times 0.06, 1 times 0.58, and etc. And then add them up, and that will represent the mean of the probability distribution. So we're not going to follow the previous methods to finding the mean. This is a specific formula that you will need to write down and remember all the time. What is the interpretation of the mean of a discrete random variable? Suppose an experiment is repeated n independent times and the values of the random variable x is recorded. As the number of repetitions of the experiment increases, the mean value of the n trials will approach the mean of the random variable x. In other words, let x1 be the value of the random variable x after the first experiment, and x2 be the value of the random variable x after the second experiment, and so on. Then x bar is going to be the addition of all of these values. We add them up and divide by how many values we have. The difference between x bar and mu sub x gets closer to 0 as n increases. The following data represents the number of DVDs rented by 100 randomly selected customers in a single visit. We want to compute the mean number of DVDs rented. If we do that, we're going to add up all of the x's and divide by 100, and we will get 1.49. As the number of trials of the experiment increases, the mean number of rentals approaches the mean of the probability distribution that we computed previously. Because the mean of a random variable represents what we expect to happen in the long run, it is also called the expected value, E of x, of the random variable. Meaning, if I ask you to compute the expected value, you're just computing the mean of the random variable. Let's see how the expected value works. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. These policies have premiums that must be paid annually. Suppose a life insurance company sells a $250,000 one-year term life insurance policy to a 49-year-old female for $530. According to the National Vital Statistics Report, the probability that the female will survive the year is 0.99791. Compute the expected value of this policy to the insurance company. To compute the expected value to the insurance company, we're going to create discrete probability distribution. We have two possibilities. We have a possibility of the female surviving or a possibility that the female does not survive. If the female survives, then the insurance company is going to get the $530. And the probability for that is provided in the question. If the female doesn't survive, that means the company has to pay the beneficiary $249,470. The probability of not surviving is basically the complement of the probability of survival. So 1 minus the probability of survival will give the probability of not surviving. The expected value we computed by multiplying the variable by the probability and adding everything up. So we will get $7.50. So we say that if the female survives, then the company will make $530. And if the female doesn't survive, then the company still makes $7.50 out of that policy. So in this case, we expect the insurance company to make $7.50 out of that policy. To compute the standard deviation, you're going to use this formula. I will show you how to use this formula in a separate video.